It's Don here from the board. Thanks for coming along and checking out this video. So this is part 2 of my series, I suppose, on switch sounds. So if you don't know what I'm talking about, you might want to go and check out part 1. The card's probably been and gone in the corner there, but you'll find it in the channel and playlist. But I talked through a setup that I came up with, designed, printed, and mounted on a microphone for the purposes of measuring what the sound profile looks like for an individual switch. Now, there are obviously going to be some issues around that, but from a simple point of view, if we do things in a consistent manner with a consistent setup, the sounds that we record can be comparable to each other, right? And that's the basic premise of it. Of course, there has been some discussions and comments from that have led to more work that might need to be done in regards to how sounds are sampled, sample numbers, the population that is sampled. So that's something to explore, because what I've done is I've taken what I said I would do in that video, which is to explore a range of different switches within the same family to see if the concept is of any value, right? So just to recap, I get a switch, I put it into the setup, I use the plunger, I plunge it 25 times and I record the audio sample from that. I remove the background noise and then I take a frequency response graph from it. I take that spectrum and then I can produce a graph and we can see how that differs in between the different switches that we check. So I've done that now for the MX Black switches that I have available to me as part of my switch collection, and let's check out what that looks like. So what I've done is I've got on my other screen, so I'm just going to turn off that camera because it's not really going to provide any value now. Here is all the sound samples for what I've got, and you'll see I took a standard MX Black, a MX Vintage Black, a Gatoron Black, a Gatoron Black that's been lubed that I had in my collection, a Kale Box Black, and a Gatoron Silent Black, right? And you'll see that that's running across the top there, and that's actually all of the data. But what I do want to do is I just want to play you these sounds and see if you can tell me if you can hear the differences between them and how you might expect their frequency response graph to look like. Now, these are the raw files. So what that means is I have not taken the background noise away. But when I took the data for these for the actual frequency response graph, I did remove the background noise. Okay, so this is the Cherry MX Black, which you would have heard from last week, but I'm just playing it again. So you can definitely hear it does seem like there's scratchiness to it, but how much of that scratchiness is actually from the switch or from the plunger, I don't know. Right, so that's, you know what, I'm just going to cycle through there. So this is a Vintage Black, probably won't play the whole sequence, maybe the first couple of presses. Oops. Okay, so it actually doesn't sound as scratchy. So we've got the Gatoron Black now. So once again, you can hear a bit of that scratch sound to it. That's what it feels like to me. Now, something that you will probably notice is the frequency and the speed and possibly how hard I'm pressing the plunger between these different switches is part of what I talked about in that first video, in that it's actually really hard to make it consistent without some kind of mechanical intervention, but that's currently out of the, I suppose, the complexity that I'm willing to invest into a setup, because that obviously takes a lot more effort. But for proof of concept, at least it's okay. I mean, yes, there are going to be consistency issues here, but when you have a look at the graphs, we'll actually see how that pans out. So here is a lubed black. Now, I'm not going to say that it's the same as if it was, say, a vintage black to a normal cherry black, but maybe? Does it sound less scratchy? So here's the kale box black. And then the only silenced black switch that I had is the Gatoron silent, which has got that little, the silicon pads that are on the top of the stem for the upstroke dampening. And what's really interesting on that is straight off the bat, you can hear echoing. You can hear spring sounds. And to me, that is a very, also in general, the silent switch profile sounds very different to the others. And I'll talk about that in a moment when we get into looking at the graphs. So I produced the spectrums, I grabbed all the data, I dumped them out, and I put them in to this. So that's the actual table, frequency against the values. And you can see, there's a lot of data involved in here. So I'm just going to try and shrink that because it's not going to, there we go, I was losing the bottom of that there. And what you'll see is I've got a couple of sheets below. So I've got the Cherry MX switches grouped together, and then I've got the Gatoron switches, and then I've got a tab which has got all of the different switches put together. So let's have a look at the Cherry switches, and that's what the graph looks like. Blue is the standard one, red is the vintage one. And really interestingly, they have a very, very, very similar curve. So in terms of consistency in how these two switches perform, it's actually quite as expected. They're both cherry black switches, and so their sound profile actually has a very, very similar shape. In terms of their volume differences, so the higher the curve line here is, which, for example, the red one here being the vintage switch is higher, means it's actually louder, okay? Louder relative. The problem is there's two parts to it. One is how hard I'm hitting, because I haven't amplified or normalized the sound, right? And then, of course, two is it because it was lubed that it's actually louder? And you might think, well, why would that make a difference? Why would a lubed switch actually sound louder? I suppose it's because potentially the downstroke won't be as greatly impacted in a lubed or a vintage switch, because it's nice and smooth going down. So it'll get the same sounds possibly, or different sounds going down. But on the upstroke, because a vintage switch is smoother, the return, the spring return is smoother, right? Against the leaf, against the housing. So it might actually be faster, lower friction, right? And so it comes up and it hits the top housing faster, and therefore generates more force, and therefore generates more sound. Okay, so that's the only thing that I could think of, stretching my understanding of physics in general, just really high level kind of physics, that could possibly explain why the vintage switch sound is actually marginally, like it's a very small difference here, okay, but it's consistently louder than the non-vintage switch. But the shape, the profile of where the frequencies lie is really close, as you would expect, because they're both the same switch. Just one's been worn in and smoother. So you get a bit of a louder bass level sound. Now this is log frequency, okay? And then, your sort of mid-range here, and then it sort of starts to get softer towards those higher frequencies, those higher pitches, right? So let's have a look at the Gatoron switches. So here's 3 of them. And we have the standard MX in green, the lubed in the blue, and then the silent in the orange. So they all have very similar shapes because they're all Gatoron switches. In terms of the loudness, the silent switch is actually louder than the non-silent switches, which is really interesting. Which is really, really, really interesting and unexpected, because you're expecting that the silent switch is going to be quieter, right? Now, if we go back and think about what I just said on the Cherry MX switch against the vintage Cherry MX switch, and we draw the correlation that the lubing might be the reason for it because it's a smoother switch, the bass levels here between the standard and lubed is about the same, but then the lubed switch is louder. It takes over. It gets louder as the frequency goes up. See how that crosses over there, and it stays for the rest of the curve. The lubed switch is louder, which it might actually fall under what I was talking about, in that the switch, the stem, the return on that upstroke is slightly faster and therefore a little bit more speed, and is hitting that top housing and generating a slightly higher volume for those frequencies. But at the lower vibrations, right, at the lower frequencies over here, it's not so much. Now, why is the silent switch higher as well in the bass area and across? And to me, I think it's because the silicon pads, the dampening pads, are actually giving it a bass sound, because it's not clacking, like it's not hitting it like that, but it's doing like a thud sound. And if we go back to the actual sound of the actual clips that we have, right? So if we take the Gatoron Black, okay, I'll just play a little bit of it again. It's got a really sort of hard upstroke contact sound. But then if we take the silent switch and we play it again, it has an echoey sound, because the dampening is sort of giving it a more of a thuddy sound, and the loud upstroke clack sound against the housing is being dampened, and it brings out those higher frequency spring sounds and the echoing chamber kind of sounds, which is what we're kind of seeing around here before, it starts to, well, I mean, we're comparing the Gatoron, the green line here, to the orange line, which it is actually more visible across the entire range. But that's just my interpretation of it, right? That's just me thinking out aloud, looking at these lines and going, what could possibly explain this, right? So then if we take both sets, and we also throw the Kale box black in because there wasn't much point in just generating a single line for that, and we put them all together, this is what it looks like. This is what it looks like. Now, I realize that the graph here is not consistent. I didn't think about that, but you'll see there's a linear black, the spectrums, 25 presses, noise reduction, but no amplification. Okay. Now the colors have changed because they've all been stacked in together. So you got the blue for the cherry, red for the cherry vintage, green, purple, which they've been exactly the same. The only ones that are swapped around, oh no, sorry, the Gateron is still orange. So the light blue is the only one that's actually changed. My bad. I obviously didn't remember that. And we can see that the standard cherry switch is actually the quietest of them all. It's actually at the bottom. Now they all follow a very similar pattern. Look at this, bit of a spike here in those really low frequencies, and then there's that dip down, but then the silent switch jumps above that, right? It leaps above that and it stays on top until we get to around this 3000 hertz area, and then it sort of sits around the same as the box black and the lubed black. But the vintage black, the standard Gateron black, and the cherry black are actually all sitting lower. They're quieter. They're quieter. Strange, right? They might sound scratchier, but is the scratchiness quieter? But why is it quieter? Is it quieter because they're more scratchy and therefore the stems don't move as fast and therefore they don't hit as hard and produce a slightly higher volume? And when I talk about a slightly higher volume, this is a 20 decibel gap, so half of that is a 10 decibel gap, and if we look at that, that's like a 10 decibel gap. Supposedly you should be able to hear a 10 decibel gap. It's very hard to distinguish a 1 decibel gap, a 2 decibel gap. When you start pushing towards a 5-6 decibel gap, it's notable. If you're listening for it, when you get to a 10 decibel gap, you should be able to hear that difference. Right? It's really interesting. The pattern, the overall pattern is very consistent. And from my previous video in the keyboard microphones series, 3000, I think that is off. My labeling is off. My numbers are off. What is this? Okay, so the frequency might be not quite right there in the labeling. Anyway, because is it 30,000 hertz? 3,000 hertz. Okay, so here we go. Engineering and science has a problem. If I go to my data sheet, boom, boom, boom. I honestly don't know. Well, no, there's the frequency. Oh, it's because it's kilohertz, right? 3,000 kilohertz, 3,000 hertz. What does the data go up to? No, the data goes up to 100,000. Yeah, okay, so it's just straight up plotted. Right. Anyway, yeah, it's kilohertz. It's kilohertz. So my bad. Is it 3,000 kilohertz and 22 kilohertz is what we hear up to? Yeah. Okay. You know what? My brain is getting fried now. I'm starting to doubt myself and what all of this means. So if you understand this graph a lot better than me, please let me know in the comments below. I'm not going to talk about the frequency range here. I just know that the lower the frequency, the bassier it is. The higher the frequency here, the more high-pitched it is, right? I probably stuffed up how that's being represented compared to how these are being done because I used a log of some sort and I didn't over here, and it was just plotted straight as is. But if we just look at relatives, in terms of their height positions, the quietest switches out of all of these that I've measured just with one switch and only 25 presses, okay, it's very important that we take that into consideration, is actually a bog standard Cherry MX Black. And the loudest of the switches is actually a Gateron Silent MX Black, just stock. But the bassiest is the Gateron, actually. And the others actually kind of hold pretty well. They don't really chop and change their rating or ranking. But what it does show you is that the Cherry switches seem to be lower than a lubed, a box, or a silent switch. Whereas the Gateron switch default sits around a vintage switch kind of sound. That green and red line hug each other really nicely, right? So if you want to replicate the sound of a vintage MX Black, you could get that kind of sound by using a standard Gateron MX Black. That's the interpretation that I would take away from this. If you want to replicate the sound of a lubed Gateron MX Black, you could use a Kale Box Black, because the light blue and that purple line sit around and correlate quite nicely. Does that make sense? It makes sense to me. In any case, look, this is just the first one that I've done with these switches. I have more switches in my collection, but not in the linear black range, right? So what do you think? Is this of interest? Is this of value to you people who thankfully come along and check out these videos? Tell me, should I go and compare reds, right? And then compare the red switches against each other, and then compare the red switches with the black switches? Because if we think by that logic, the same housing with the same material, because the red stems will be the same material, they're just a different color, right? With a lighter spring should produce a quieter switch, because I'm talking about a heavier spring pushing stems up faster so they hit harder, so they have more volume, and a lube switch being louder because it has less friction, so it comes up harder and hits louder, right? So a red switch with a softer spring should come up slower, should hit less hard, and be less loud. Will that actually show up? Will that show up? Do you want me to look at this with tactile switches? Do you want me to look at this with clicky switches? I don't want to go down the effort of doing more of these and just doing my head in with these frequencies and log graphs and everything else if you guys, the community, don't give me the feedback that it's actually interesting enough or of value enough to do it. So please, hit that like button if you like this kind of stuff and you want to see it. Just comment below and tell me if that's of use or interesting, or you just want to see more. Or tell me you want me to try just one switch and doing it more and more and more and more, right? So rather than 25 presses on one switch and getting a single curve, which is like what we've done with these, is to maybe get 2 or 3 switches and doing a lot of them and then checking it out, right? Or maybe even one switch doing 25 presses, saving that, and then doing that same switch, 25 presses again, and seeing the differences between it, because it's 25 really accurate and representative. If I do the same switch and I batch it in a number of 25 presses, or even one press, just record one press and then record that and compare it against a number of single presses, how much variation is in that, right? There's so many options available with this kind of setup, and just, is it worthwhile exploring it? Tell me, right? Tell me so I can do it and do more of this so you guys don't have to. So there you go. There you go. Hopefully you enjoyed that. And if you didn't, of course, please let me know. Yeah. Of course, I'm just going to finish with the standard that everybody wants, which is like, subscribe, bell notification, all that kind of jazz. Well, that's it. Yeah, that's it. Well, thanks for coming along and checking out the video, and, of course, as usual, until next time, happy clacking.